in Unit 5, we're going to start looking at algebra, a review of algebra, but we're really going to cater it towards preparing you for a calculus course. So we're going to see a lot of concepts that you've probably seen in your previous classes, but we're going to try to elevate them a little bit more. But to begin, let's just do a quick review of solving linear equations in one variable. So this should be very straightforward. 2x plus 1 equals -9. We're going to start by subtracting 1 from both sides. If I subtract -9 minus 1, that's -10. And then our last step is to divide both sides by 2. We get x equals -5. When we're looking at equations like this, just a few steps, sometimes we won't actually write out the step that we're doing, just the result of that step. So you're seeing here, I'm not actually showing the -1. That doesn't mean that you don't need to or you couldn't. Certainly a good thing to do if you notice yourself making tiny errors while you're working. -2 times the quantity 3x minus 1 plus x equals 14 minus x. So for this equation, we want to start by distributing on the left-hand side and trying to simplify that left-hand side. So if I distribute that -2, and sometimes I like to show those little rainbows or arrows just to ensure that I do that distribution completely. So we get -6x, and -2 times -1 is +2, plus x equals 14 minus x. Again, on the left-hand side, because I have like terms, I want to simplify those. -6x plus x is -5x, plus 2 equals 14 minus x. And at this point, we know we want to combine like terms on either side of the equal sign. So we want to get all of the x terms on one side, all of the constants on the other. A trick I like to do is start working with the variable terms. So I've got a -5x and a -x. What I want to try to do is move one of those so that I end up with a positive coefficient on x. Now, the reason I suggest that is because I've seen in a lot of cases in all my years of teaching that we tend to make more mistakes when we're trying to divide by a negative rather than taking a negative and dividing it by a positive. So if I have a positive coefficient on x, it makes that last step of dividing to get x by itself a little bit more straightforward, and it does reduce some potential error. So I'm going to add 5x to both sides. The 5x is on the left side, sum to 0. So we've got 2 equals 14 plus 4x. Now we're going to subtract 14 from both sides. So we're left with 4x is equal to 2 minus 14 is -12. Dividing both sides by 4, -12 divided by +4 is -3. Seven over 2x minus 5 divided by 3x equals 22 divided by 3. We're going to see some more examples of rational equations, but this one, we're going to just do a quick review. To clear the denominators in this equation, we're going to multiply through by the LCD. Looking at this equation, we have denominators of 2x, 3x, and 3, so that LCD is going to be 6x. So I'm going to multiply each of my terms by that LCD of 6x. Now that I've multiplied each term by that LCD, I can simplify each one of these fractions. So starting with the first one, 6x divided by 2x simplifies to 3. 6x divided by 3x simplifies to 2. And 6x divided by 3 simplifies to 2x. To further simplify, I've got 3 times 7 for my first term, or 21, minus 2 times 5 is 10, equals 2x times 22, or 44x. And now we cleared those denominators, making this a pretty straightforward linear equation. 21 minus 10 is 11. which equals 44x. Dividing both sides by 44, your awareness of your own ability to simplify mentally is going to be, really what decides whether or not you show that division or not. For me, if I know that it's not going to divide evenly, so if I'm going to end up with a simplified fraction, I like to set up those fractions. It helps me simplify them a little bit easier. So 11 divided by 44, that's going to simplify to 1/4. Now, whenever you have a rational equation that has variables in the denominator, you need to make sure that your solution does not make any of your denominators equal to 0. So if I were to plug in 1/4 into any of those denominators, we would not result in a denominator of 0. All right, so that was when we're solving a linear equation, we only have one variable. Now we're going to look at reviewing linear equations in two variables. So this is where we start having both an x and a y, and we're looking at things like graphing. So there are three versions of a linear equation that we're going to review. The first form is called general form. So this ax plus by equals c is our general form. General form is most useful in calculating both the x and the y intercepts, but that's about it. We don't typically graph otherwise with an equation in general form. The next form, this y equals mx plus b, this is our slope-intercept form. By looking at an equation in slope-intercept form, we know the slope and we know the y-intercept. So that gives us a point to start with, and then a slope to find additional points when graphing. And then the last form, this y minus y1 equals m times x minus x1, this is called point slope form. Point slope form, you can see the slope and a point different than the y-intercept that your graph goes through. So whether your equation is given in slope-intercept or point slope form, you're starting from the point that's given. With the slope-intercept form, you're starting on the y-intercept. With point slope, you're starting with that point that's given, so just some x1, y1. And then from that point, you're going to use the slope to plot additional points. Now, we've been talking about slope a lot. Let's just review slope of a line. Sometimes referred to as rate of change, and especially as you get into calculus, we refer to it as rate of change a lot. This is the change in your y values divided by the change in your x values. We're all familiar with the formula for slope. We use the variable m to represent slope. Slope is equal to y2 minus y1 over x2 minus x1, which is also thought of as your rise over your run. So that change in your y over the change in your x. Find the slope of the line containing the points 3, 7, and -3, 5. Since we're given 2 points, the most direct approach would be to use the formula and solve for the slope algebraically, as opposed to graphing the 2 points and counting your rise and your run. Graphing takes time, so if we don't have a graph provided like we see in the next example, we want to use that algebraic formula. So our slope, y2 minus y1 over x2 minus x1. It doesn't matter which point you call x1, y1, x2, y2. Just be consistent. So in the order that they were named, I'm going to call this one x1, y1, and the second point x2, y2, but it really doesn't make any difference. So y2 was 5, minus y1 was 7, divided by x2 was -3, minus x1 is 3. Simplifying the numerator and the denominator, 5 minus 7 is -2. -3 minus 3 is -6, and this simplifies to positive 1/3. Now, in terms of our slope, sometimes it does help us to kind of sketch this out to make sure that our slope is reasonable. So if I think about trying to sketch these 2 points, 3, 7 is in quadrant 1, negative 3, 5 is in quadrant 2. So I can quickly just go 1, 2, 3. So 3, 7 is here, negative 3, 5 is about here. So connecting those 2 points, we can see that we've got a positive slope, so that's good, we have the right sign. And it's not a very steep line, so having a slope that's a fraction seems reasonable. Unless you're doing your sketch on actual graph paper, checking the accuracy with this graph is going to be a little bit more challenging. All right, find the slope of the line given the graph. So there's a couple of options, but really what we want to do to start is to pick 2 points on the line that intersect at crosshairs. In other words, I don't want to pick this point because I'd have to approximate that ordered pair. Rather, we want to pick points that are on those crosshairs of our grid. So there's one and there's one. So I'm going to use the points 0, 3 and 3, 5 to figure out my slope. Now I can do this visually from the graph by counting the rise and the run. So I'm going to go up 2, so that's a positive 2. M is 2. And then to the right 3, so that's a positive 3 as our run. So that slope is 2/3. You could also use that same slope formula that we used in the previous example using these 2 ordered pairs. Bottom line is we want to make sure that we are using exact ordered pairs that don't require any approximation. Find the equation of a line with a slope of 2/3 that goes to the point 0, 5. Anytime you're asked to write the equation of a line, you need 2 pieces of information. You need the slope and any point. Any point on the line, excuse me. We are given in this equation, we're given the slope and we're given 0, 5 is a y-intercept. Since the y-intercept is the ordered pair 0, 5, that tells me that b is equal to positive 5. So because I have slope and y-intercept, I can directly plug into that slope-intercept form. My equation is y equals 2/3 x plus 5. In the next equation, we're finding the equation of a line. We want to leave it in point slope form through the points 2, 3, and 4, negative 5. Regardless of what form we're trying to leave the equation in, to write the equation of a line, we need the slope and any point. Well, we are given 2 points, so we've got that any point part covered. The slope we now need to calculate given the 2 points. So my slope, y2 minus y1, negative 5 minus 3 over 4 minus 2. Negative 5 minus 3 is negative 8. 4 minus 2 is 2. So our slope is negative 4. Now the directions indicate that they want the equation written in point slope form. So we're using this y minus y1 equals m times x minus x1. Our slope is negative 4. And the x1, y1 is one of the given ordered pairs. It doesn't matter which one you use. I'm going to use 2, 3 because they're both positive, so I don't have to worry about changing signs. So it'd be y minus 3 equals negative 4 times x minus 2. Again, since this example asked for the equation in point slope form, we're going to leave it just like this. If it doesn't specify, oftentimes we would simplify to write this in slope intercept form. Parallel lines are equations that have the same slope and different y-intercepts. If we happen to have the same slope and the same y-intercept, those become the exact same line, and then they're not parallel because they intersect at every single point. Remember that parallel means that these two lines will never intersect. So some examples of parallel lines: y equals 3/4 x plus 1, and y equals 3/4 x minus 5. So they have the same slope, but different y-intercepts. Perpendicular lines have slopes that are opposite reciprocals. Now, it doesn't matter if they have the same y-intercept or not, because their slopes are going to be different. They're definitely going to intersect. Some examples of lines that are perpendicular: y equals 3/4 x plus 1, y equals -4/3 x minus 5. So if we look at the slopes, the coefficient on x, 3/4, the opposite reciprocal, opposite means change signs, reciprocal means flip that fraction. Y equals -4/3 x minus 5. Find the equation of the line perpendicular to the line y equals 1/4 x minus 3 and goes through the point 9, 1. Again, to write the equation of a line, we need the slope and we need the y-intercept. But we're being told that the line, the equation that we're going to write, has to be perpendicular to y equals 1/4 x minus 3. So the slope for this equation is 1/4, which means the slope of my perpendicular line needs to be -4/1 or -4. And it's going to go through the point 9, 1. We can use point slope form, so we're not given the y-intercept. We can't plug in a value for b. We could use point slope form like we did in this previous example, where we plug in our slope and our coordinates for x1, y1. But I'm going to show you another technique that does utilize slope-intercept form, since that's typically the form we want to leave our equations in. So I'm going to use y equals mx plus b. I know the slope is -4, so I've got y equals -4x plus b. And I need to figure out what is the value of b. To do that, I'm going to plug in 9 and 1 for x and y. So y is 1 equals -4 times 9 plus b. And now I can solve this equation for b. 1 equals -36 plus b. Adding 36 to both sides, we get b is equal to 37. And now we're just going to plug that back in. We had this equation where we just needed to find the value of b. So we've got y is equal to -4x plus 37. We would arrive at the same equation even if we had used point slope form, just a different option to writing that equation.